Hello. Hello, Mr. Harry, Mr. Ryan. How are you today?
Good.
Okay, look, there's a triangle, number triangle. Okay, so today our job is to come up with an approach to find the minimum path sum from the top to the bottom. So can you find every time you can go to the left or right? Yeah, and then the number of score is the number of is the numbers you pick. Right? For example, you can pick this 2, 3, 6, 1. So your score will be 5 plus 6, 12. Okay, you 12. Can you find another path with the minimum?
2, 4. No, wait. With minimum.
Yeah, minimum. I wanted the minimum. Minimum path sum. Path sum. Okay. So you can go to the left.
2, 3, 5, 1.
2, 3, 5, 1. So what's this? 11.
Yeah.
Yeah, that's the minimum. Yeah, you cannot find any other path which is smaller than this one, right? Yeah. So look, 2, 4, 5, 3, and 2, 4, 7, 8 is more than the 11. So 11 is the optimal answer we're looking for. So, any idea how we're solving that? I mean, this is kind of triangle.
You just go.
You add all the smallest numbers in there.
Yeah.
And
in
the
each
small,
line.
In each line.
Good try.
Small.
Small, but it may not be. Look, you saying you pick the smallest, yeah? Yeah, that may work, but in some cases it may not work. I need to come
What
up
type of case?
Okay, good question. I need to come up with a case that the picking the minimum is not. For example, like if I swap with, I put a 2 here, right?
Yes.
Yeah, 2 here, right?
Yeah.
Yes.
And then I put minus 10 here.
Yes.
Okay, you can contain the minus. Look, you pick the smallest, 2, 3, 5, but 5 cannot go to here, right? You cannot pick minus 10, alright? Yeah, because it's not on the left
So
and right.
2 is 2, 3, or 8, and 2 the smallest.
What does minus 10 mean?
You add it. Look, 2, 3,
0
6, and minus 10. Yeah.
Minus 10.
Yeah. You plus. You can also minus, right?
Oh, okay. So you whatever Ryan said, I'm not gonna repeat that again. So you look first. Where is the minus number? Okay. So then you try to make 10.
Try to make 10. The thing is that you cannot pick the smallest in the fourth row, right? Because when you pick the smallest,
like 2, 3, 5.
2, 3, 5. But 5 cannot go to minus 10 because it can only go to the left and right. Do you get it?
Oh yeah.
Yeah. So your approach may not work.
Okay.
instead.
So wait. Okay. Let's see.
If you can't find a solution, what kind of algorithm are you trying to solve?
Okay. Wait.
Well,
Wait. I don't.
you don't know. How about brute forcing?
Oh yeah, I should have said that.
Yeah, brute forcing.
Dynamic programming.
Yeah. Okay. So this is the topic.
No, but-
Yeah. Wait. No. Yeah. So brute forcing. How can we brute force? We can brute force all possibilities. Yeah. Yeah, and we find out. We find out the minimum, right? So how many paths altogether? Look, for each one you have 2 possibilities. Yeah. If there are n rows, n type of rows, and each one you have 2 possibilities. So how many? How many possibilities? How many ways can you pick? How many ways here?
2.
3.
Why is it
2.
3?
2.
No, what I meant is from top to the bottom. How many possibilities?
No, 4.
4?
2.
Just 4?
3.
How is that? It's more than 2, obviously. I mean,
5.
you're guessing. You're just guessing.
9.
10.
Each one, look,
6.
I have 2 possibilities here. And then here I have 2 possibilities. I have 2 possibilities.
6.
I have 2
8.
possibilities. I have 2
8. 8.
possibilities.
8.
4,
8.
8, 16. Come on.
How?
How high will it be? Each one, I just say each one has 2. And then you have n rows. So how
16.
one,
Square.
maybe, wait.
Anyone
2,
know what's a cheese
one.
sandwich?
Look. 1,
I love cheese.
2, right? 3, 4, 5,
6.
6, 7. Actually, it's 7. Sorry, you are right. Because 2 to the 1,
Yeah!
1. Look, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. So 2 to the power of 3. Okay. Yeah, right.
Yeah, Daddy.
Okay. So imagine if there are 100, this approach you would do 2 to the power of n, right? The O, right? And for each one, you need to find the minimum, right? So that's the time complexity for the brute force. Yeah? So we can use the dynamic programming. How can we do it? Look.
Oh, memorization.
Yeah.
Memorization.
No,
Yeah.
look.
But the
Top
thing
down.
and bottom up. Look,
No,
look,
but-
how can we apply it? Look, listen. So for example, if we are here, yeah, if we are here,
Then you can choose 2 or 3.
you can only come from these two sides, yeah? Yeah? So we pick the minimum, right? Because look, we can turn this, let's turn this triangle a little bit tilted, okay? Tilted. So that will be 2, 3, 4. So it become a list of a list, yeah? 2, 3, 4, 6, 5, 7. It looks like triangle, Pascal triangle, yeah? But not exactly, okay? So look. So if we want to go through this, yeah, go through this position, and then you can come from here or here, right? Right? Am I right?
Yeah.
So if I want to come here, and then I have two choices, it could come here and then here, right? All right?
It's minus 10, not just 10. It's minus 10.
Okay, that doesn't matter. It doesn't matter. Okay, so look, I can come from two positions on the next row, right? Am I right? Yes?
Mm-hmm.
So I always pick the minimum. So for this one, I always pick the minimum of these two, and then plus itself, right? So does it make sense?
Yeah.
So look, if A to B, right? If A to B is 10, right? Right? And then you feel A to C and to B, this is 2, this is 3. Alright? Yes?
Yeah.
So look, and another, if the path consists this bit, and then I want to go to here. So the shortest path can always be replaced by ACB, right? Because ACB is shorter than AB, right?
Yeah.
Alright? So does it make sense? So if a shortest path come from what? Come from 5, right? Come from 5, yeah. The shortest path come from 5. Then I can always pick the smallest from these two, right? Which is 2. Alright?
Yeah.
Yeah. Does it make sense? So it means that when I determine, let's say f function, okay, f function, row and column, right? If I calculate f column R and C, it does not affect, this value will not be changed, right? Alright, look, because I already calculated it's only based on fr plus 1, which is here, and fr plus 1 c plus 1, which is the 3, and I pick the minimum, right? Alright? So let's define a dynamic programming function, which is FRC. So meaning that from the minimum past sum from the last row, yeah, from the last row, okay, last row to here, to this point, to this position. Does it make sense? Alright? Does it make sense? So it will be what? FRC equals minimum of what? Of what plus what? Can you guess? Look, FRC is the FRC is here, right? RC.
Remind
Look,
me of cheese.
look. It's coming from what? Can it come from what? Two possibilities.
2 angles.
No, I mean I'm
C
at
or-
RC, and what is next is R plus 1 C, and what is next? R plus 1 C plus 1, right? Right?
Yeah.
Because it can only come from this position. If I want to, the starting point is, look, the starting point is at the last row, and it's like climbing, right? You can climb you can climb up, right? Or you can climb this way, right? So you can climb from the bottom to the upwards. You can have two positions, right? So minimum at this point, RC, it could come from two positions, which is F, R plus 1, C, and 1. And can you tell me what is here? I was just saying RC, this position is RC. And it comes from what? R plus 1, C. And what's this position? What's this position?
R plus 1, C plus 1.
Well done. Look, so F, R plus 1, C plus 1. But look, it coming from this is the past sum, yeah? But when I reach here, I need to add the number of current point, right? Yeah? So let's define FT, RC, right? Yeah? Okay, so the final value is what? The minimum past sum, which is what? Which is the value we want to find, is F or what? The top value, which
C.
0 what? Because the top row, yeah? 0 what?
0.
Yeah, this is the value we are looking for. When we calculate this, yeah? Each value is the minimum of its next row, two values, right? Plus its value of itself, am I right? It's like picking numbers along when you climb up, right? Yeah? Can you get it?
Yeah.
Because how many numbers, the past sum have you picked previously? Is these two, right? And what can you pick from the current position? Is these two, am I right? So what's the minimum strategy I want to at this point? I always pick the smallest, right? Yeah? Because I pick the smallest. That's the smallest. That's the ultimate strategy, and I attempt it. I add it with current numbers, right? Does it make sense, Eric?
Yeah.
Can you explain again?
So, you wanna find the. You wanna say.
Okay.
Okay. So, so you only can go. This is R plus 1 C, and this is R plus 1 C
plus 1.
You pick them. RC is this one.
Yeah. So basically, look, you want to find a minimum past sum, yeah?
Yeah.
Past sum from the top to the bottom, yeah?
Yeah.
Is it the same as from the bottom to the top? Am I right?
Yeah.
It's the same, yeah? You want to add a number, find a minimum pass. Find a minimum pass sum from top to the bottom. It's the same as from bottom to the bottom, yeah? Up, yeah? It's like Eric is here. Ryan can pick here or here. You can start with any position at the last row, yeah? And then you can climb it up, yeah? Look, you are here. You can climb here, and then you can climb here. When you climb here, you have 4 plus 2, which is 6. When you climb here, you have 4 plus 5 is 9, right?
Yeah.
So here, when at this point, you will be 9 here, and then you will be 6 here. And then here you can say, but look, 6, this is 6, but here, look, 3 plus 2 is 5. Well, if you want to reach this point, it's better you pick this one, because this is 5, right? Yeah? 2 plus 6, this is smaller, so you put 5 here. So 5 and 9. You want to climb to the top, you pick which way? You pick which way?
When we were?
Here, this is 5, this is 9. You want to climb to the top. Which way you want to choose?
5.
5, because yes, 5 plus 1 is 6, and 9 plus 1 is 10. So you pick 6. The optimum is 1 plus 2 plus 3. Got it? Does it make sense?
Yeah.
Why can we do it? Because when you reach this point, I don't care how many paths you reach this point. I always pick the smallest. So for the any step, for the 1, right? It doesn't care how many ways you calculate before 2. You always the smallest, which is 5. 2 plus 3. Yeah, got it? Does it make sense? Yeah. Okay. So look, this is the minimum function. Yeah, this is the dynamic transition function, right? Got it?
Transition function.
Okay. Look. Let's do this way. Do this one more time, so you know how we're doing it.
Let me do one.
Okay. Look, Eric.
Oh.
Look. let's see. Let's go in from the last row to the top row, okay? And we want to calculate the minimum. What's the minimum? What's
2
the,
for 3.
which is 9, yeah?
Yeah.
You remember this is 9, how we get it, okay? 4, look, here is 4, yeah?
Yeah.
3 and 8,
11.
which is smaller? 3.
3.
3 plus 4 equals 7, right?
7.
And 7. Here, 5 and 8 and 10, which is smaller?
8.
8 plus 5,
13.
13, okay. And here, 7 and 13, which is smaller?
7.
7 plus 2, 9. So this is the optimum. Got it? Does it make sense?
Yeah.
So for any large triangle, I don't care. I just do this from bottom to the top, right?
Yeah.
Because this is always satisfied. This is always the dynamic programming transaction function. What's the advantage compared to the brute force? Look, previously, there might be a lot of paths coming through, right? Duplicate paths, am I right? Look, previously, if you don't remember, Eric, look, if you don't remember don't memorize the path sum till this point, and you may calculate again and again. For example, look, you calculate here. So for example, here is 10, right? And then you want to calculate here, you get the 1, add the 2, add the 3, add the 4. But again, for each path sum, you need to calculate this over and over and over again. But for now, I don't calculate over and over again. I just save it in FRC. And I can just pick the minimum, right? So it will be a lot faster, right? Does it make sense?
Yeah.
Because this part is fixed, yeah? Once I calculate it, I don't need to calculate it again, okay?
The middle one.
Okay. What? 7?
Hmm.
What? Then you can ask Ryan.
Okay.
7, 8, minus 3, okay?
I'm gonna do 1.
Mm-hmm.
Yeah. Okay. 3, 6.
Okay, so look, this one, yeah? 1 and 3, pick the smallest 1, yeah? 1 plus 8, 9. I put a 9 here. 3 and 6, pick the smallest one, 3. 3 minus 3, 0 here. 0 and 9, pick the smallest, 0. 0 plus 7, 7. So the number is 7. Yeah, got it? Does it make sense?
Yeah.
Yeah? Okay, so this is smaller, maybe you can just try every possible path. But if a triangle it has a million lines, then it's not feasible, right? Yeah, you don't know which one, but you can always try this strategy from the bottom line, right? And build this dynamic programming metric along to the top, right? Got it?
Yeah.
Okay, look, this one. How many dynamic programming are we talking about? I asked this question, Lo.
Top down, bottom up, which
Two.
is 2.
Yeah, okay. So define, let's try this F R C, okay? If, okay, let's say, if R equal, let's define a number, define the mean cost, okay, mean path sum, okay, mean path sum. And then we are given a metric which we have we call it T, okay, triangle, okay, column, okay. If R equals the last length, yeah, the last row which is length T, right, minus 1, yeah, because it starts from 0, okay. Yeah, if it's the last row, then what we return? If you're on the last row, what should we return? If you are at this triangle at the last row, what should we return?
Return R.
The value at here, right?
Yeah.
So it's T R C, right? Yeah? Alright?
Yeah.
Otherwise, I return what? If it's not in the last row, then we return what? Minimum of F what, Eric? I just told you.
Oh, wait, let me remember. R, C. No,
Huh?
R plus 1, C. R plus 1, C plus 1.
Yeah, and
Yeah.
again, and you forgot something. In here, you need to pick up value, which is
Plus
TRC. Yeah, this is the value. Yeah. Alright?
Yeah, I'm.
Okay, what's missing here?
No, cash.
Cache. Because if you're not doing the cache, what happened? If you're not putting this, what happened?
Take.
That will be the blue false we just talked about, right?
Yeah.
That would be, for example, now if you calculate something in R divided by 2, C divided by 2, that will be maybe many times you want to calculate this function again and again and again and again. So now what's the time complexity if you add this cache? What's the time complexity?
Quite fast.
Oh, what? How many values are we do we need to calculate?
The R and C.
R times C or R and C?
I think probably.
Not probably. Come on. There are and there C. How many? What's the area of this triangle? If this is R, this is C.
Probably times.
Not probably. It's times. Okay. Remember.
Yeah.
Come on. This is a square. R and C. What's the area? What's the area of
You
it?
want to work out the area.
Yeah, area. What's the area?
Area is the inside.
Yeah. How many?
Which?
R times C. Yeah.
Yeah.
What's the triangle?
The
R
triangle.
times C divided by 2, right? Yeah?
Yeah.
Because it's half of it, right? R times C, and this is half times C divided by, we drop the constant, so it's R times C. If we're not adding the cache, what's the time complexity?
Like super slow.
Super slow. It's
01.
2 to the power of R, right? Yeah, because each row you have roughly here. Yeah? Exponential, am I right? If R and C equal, if R equals C, right? Right? I think R equals C. Yeah. Okay? So
Bye.
now, what's the another approach we're talking about?
Button up.
Bottom up, yeah. So bottom up. Let's try this bottom up. Define.
Yeah.
So I think the top down is easier to implement. Am I right? Am I right, Eric?
Yeah.
Because top down we can usually implement it using
It's
recursion.
short.
Recursion with what?
Top down. Minimization.
Minimization with a notebook to remember it, right? Define, let's
Cap.
say min. No. Min pass sum. And we can
Cap.
keep.
Top down.
Okay.
Column.
Okay, so look,
Yes.
let's say row
my pen.
rows equals length t, right? Okay, so look, let's define. We can put a value, update the value in a triangle. So let's do for row in range. We want to start with the second to last row, right? Alright?
Yeah.
So it's rows. The second row is the last row is rows minus 1, right? The second to the last row is rows what?
Second to the last row is rows at
No, minus what? Minus 1 is the second last row. Minus 1 is the second last row.
minus.
Come on, this is rows minus 1. So what's this? Rows what?
Minus 2.
Yes, come on. What's the
the
and what's the
bottom.
top one is 0, right? So but we have to fit it is minus 1 because it's the up to, right? Remember this range function, yeah? When you put a range 3, 5, what happened? Eric, range 3, 5, how many numbers are in there?
Oh, 15.
No, start.
Two.
Stop.
2.
2? Yeah, so it's 3 and 4, but not including 5, right?
Yeah.
But you can do this negative, so it's 3 minus 1 range. This is step. So what's this? Range. So what's the value? Range. What will you give? 3, and then what's next? Sorry? 6
minus
what? 3 minus 1 is what?
2.
And then what's next?
1.
And what's next?
0.
And what's next?
Minus 1.
But not including minus 1, right? This is always the value before this, right? So 3 minus 1 is actually 4 value. 3, 2, 1, 0. Does it make sense?
Yeah.
5, 8. What's the value?
5, 6, 7.
Yeah, we're done. Okay, another one. 5, 8, 5 minus 1. What's the value?
Is minus 1 step.
Yeah, step. So what's the value?
8, 7, 6.
Yeah, not 5. Yeah, we're done. Good job. So look. So next, rows minus 2, minus 1. You will do the last value will be what? Minus 1. The last value will be what?
Minus 2.
No.
Minus 0.
Minus 0 is what?
0.
Yeah, 0. Okay.
Yeah.
Got it? And for I in that, and for C in range, look, the line will be length, TR, right? Because TR, this row, right? Okay, look. TRC equals what, right? TRC equals what? Mean what? Right?
Oh, right. F.
No, F, this is T, we are talking.
Oh, T.
T, what?
R. Add 1. C. And then
Another one is T, what?
T. R. Add 1. C. Add 1.
Okay, and what's
Add
what here? Add?
T. RC.
Yeah. So actually TRC you can just add equal, right? Add equals this value, right? And then return which one? Return what value we are looking for? Return what?
Return minimum.
No, return which value is the minimum per sum?
RC.
No.
R.
Come on.
C.
We are calculating
No.
from here to here. So what's the last value?
No. It's minus 1.
Yeah.
0.
What's 0? Come on. I just told you. Come on. Remember.
0.
T00, yeah?
Yeah.
Previously, remember the f function RC, right? So what's the value is you need to return f00, right?
Yeah.
Right? Got it? When the top down dynamic programming, you return f00, right?
Yeah.
But this one bottom up, the final value is on the top. Come on.
Yeah.
Does it make sense?
Yeah.
Does it make sense? Okay, now I'm going to erase it. Okay, remember, okay? I'm going to erase all of it. Be here. Come on. Return T. I write this for you, okay? T00.
I don't know the beginning.
What the meaning?
I.
TRC, okay?
Okay.
Okay. Right, you write it.
Is it equals?
You can do like equal, that's fine. TRC, we want to update the value in TRC.
Yeah.
So what does it equal? You need to pick the value from the next row.
Cool.
Add equal, yeah? Or equal, doesn't matter. Equal, yeah?
T.
Okay.
3.
Yeah.
Okay. T.
Yeah? Keep going, RC, yeah? You want to pick the minimum, right?
Oh yeah, I forgot min.
You put the add equal here, add equal.
Okay.
Because you want to pick the current value, but also the minimum in the next row, right?
Then
Mean.
in the bracket
Yes.
or not in the bracket.
Mean, you write it.
Okay, I write min.
Okay, bracket. Yeah. Not the bracket, bracket. Parentheses.
Yeah.
Okay, and the next value.
Maths.
And the next value. Next value.
I guess it's T.
T, yeah, keep going.
And
Next row, which is
bracket.
yeah. Like that, yeah, come on. T is a way, and then, yeah.
Now I'm gonna speed up.
Bracket,
Oh, I forgot comma. I forgot clothing.
yeah.
Forgot clothing. What?
Wait, look,
Lick
this
it.
one. This thingy.
Yeah. Yeah, and then,
And then
comma.
comma.
And then what? You can write it here if you want. Not finished yet, almost. T.
Oh yeah, T.
And then there's a bracket here. Okay, you need to do it like that. Do it like that. Yeah, and yeah, okay.
Okay, add.
Add if you want to add TRC, yeah, TRC. Okay. Because TRC, you want to pick the value. You want to keep the current value with the and then pick the minimum in the next two options, right? Got it? Does it make sense?
Yeah.
Okay, good. That's it. Okay, say bye bye to people and see you tomorrow.
Bye.
And bye.
Mr. Banana Bar.
Okay.
Go, Mr. Banana.
Okay, that's it. See you.
Bye.